Well, hello again. We're here to take a look at how you can complete the lab report for the Coffee Cup Lab. I've put a blank template together, which everyone has shared in Google Classroom, and I'm going to show you a little bit about how you can complete it. Now, at this point, most people have done the top of this report, but I'll show you some of the things real quick. You should certainly replace the name and other identifying details at the top with your material like I'm doing here. I'm just going to get rid of this identifier name. The date today, I guess today is January 13th, 2019. The Patriots won today. Had a great time watching them win. Class could be science, and of course the teacher would be Mr. Wallstrom. A little strange that I'm in my own class, but I think you get the idea. Title, you can make up any title that's appropriate, but I'm going to go with Coffee Cup Comparison Lab. That seems like a pretty decent title. All right, everything's spelled correctly, centered up, we're good to go. Now you're asked to create an experimental question. That's what drives your testing. A reasonable experimental question might be something like, what cup holds in heat the best? I'll use that. What type of coffee cup holds in heat the best? Don't feel that you have to duplicate that exact question. Your wording's fine as long as it's grammatically correct. Don't forget to put it on a question mark, use appropriate grammar, spelling, etc. Everyone should have a hypothesis. Let's leave that space in there. Your hypothesis is a proposed result. We had 8 different cups. Every group was asked, or every individual was asked to pick the cup that they thought would be the best. And your hypothesis should be specific and I think include a little bit of reasoning. So I'm gonna make up a hypothesis. I'm going to just make something that's a little bit ridiculous, but I think the 12-ounce paper cup with a lid will be the best. I don't want to say best. Let's use something a little more specific. Will hold in heat longest and show the least temperature drop because it is the most common type of cup. All right, that's a hypothesis. I see I got a spelling error. It's pretty easy to fix up. I don't think that this reasoning is true, and it's not intended to be. It's just to give you an example of what you might do. I think that you should use better reasoning related to the design of the cup, the materials, whether or not it has a lid, and things that you believe will affect its performance. Moving down to your variables, you're asked to identify the independent, dependent variables and several controlled variables. You've got room for 3 here. If you need more, just insert rows. You can do that easily by right-clicking, a double click or a right click, and insert a row above, and you can add lines and just write controlled 1, 2, 3, 4, 5, and so on. I'll get rid of that right there. All right, anyway. Your independent variable, the description should just be the name of the variable. So I think we agreed that the independent variable in this test was the type of cup. You can capitalize it. I think it's nice to center things like this, makes them look good. And an explanation could be something like 8 different types. Oops, excuse me, I should get some spelling right. Tested side by side. All right, I think that's kind of nice. A common, let's go with common types of coffee cups were tested side by side. Now your dependent, of course, is what you're measuring in order to get the results. You should know that by now. And then controlled variables. You should come up with more than one. You should think about this carefully and come up with as many that you think are important to ensuring this is a fair test. Students have included things like the initial temperature of the water, that it's important to have all of the water that the cups were tested at the same temperature so that there was no unfairness in it. Others, the amount of water. There are certainly lots of variables that could impact this, so you should give each one a name. That will go in the description column, and that should be very brief. Something that's just kind of like simple to say and identifies what you think needs to be controlled. And then in the explanation, give it a little bit more. Please write in complete sentences, grammatically complete sentences, and explain to your reader why you think this needs to be controlled or what you're doing to control it in order to make this a fair test. Again, fill in as many of these as you think are reasonable to make this a fair test. Your judgment matters, but one or two are probably not enough. All right, so going down to the method, again, we want to click next to it, and we're going to do our typing directly underneath it. I like to keep these headers kind of on their own. I think it breaks up the report and gives it some nice spacing. Your method should describe how this lab was completed. It should be an outline of the lab. It should not get into every detail, for example, how to set up a lab stand and how many minutes the microwave ran to heat up the water. But it should be a kind of an outline of what was done so that another reasonable group of people in another middle school that weren't here in Paxton could duplicate our work and create a very similar lab to test our results. So to that end, I might, I want to think about what I want to include here. And I might want to say something like 8 different coffee cups were tested in a side-by-side format with by teams of students. Each cup was tested by one team. Should probably correct coffee. Okay. And the results were shared for analysis. And then you might go on to say, for example, that they were set up on lab stands with thermometers inserted, that microwave was used to heat all of the testing water, similar quantities of water or the same quantity of water to the same temperature. They were poured into the cups and temperature was tracked once a minute for so many minutes in order to produce a data set for how quickly water cooled off in that type of cup. You should draft a method that allows somebody else to duplicate the work that we did. Hopefully that's enough to give you an idea and allow you to move forward. Okay, so data and results. We want to include information here that came as results from the lab. It's important to have a nice introduction, give some information, some context for your reader to help keep them understanding what they're finding here. So let's think about that. We might want to say that the class's data was combined into a single table, that is being presented below. Tell them what your cup number was. I think it's important for them to know which cup you completed. This is a great place to do that. My group completed the data for cup 5. Other students did all of the other 7 cups. And things like that. That would be your data and results. Again, write in complete sentences. This is formal writing. You should be communicating clearly about what your reader can find in this section for information that you got out of the lab. Your next section is the analysis. Oh, hang on. Let's not go there yet. After you've done your introduction, so I'm going to write introduction, well, we could make up some kind of a sentence here. So the table below presents class, and I'm just going to go like this. This should not be bold, right? The bold should only be the header. So that's going to be my intro. And then underneath it, I'm going to want to couple of spaces here, and let's paste in that table. So we created this table a little while ago. This looks good. We can highlight the data. Oops, I think it's important to include that top label. And we can copy this. Right-click copy. And we can go right over to this lab report, and we can paste it right on in. There we go, paste it. Linked or unlinked. So if you link it to the spreadsheet, if you make any changes in the spreadsheet, it'll also change in the document. That's great if you find mistakes later on. Unlinked, it just pastes a copy of it as it exists at this time. A lot of students are going to have some difficulty getting this data table to fit in the space provided. It's not likely to fit into a single, I see a spelling error here, I'm going to fix that. It's not likely to fit into a single page. So you may be able to make some strategies, take some strategies that may help it fit in a page. More likely it's going to have to be broken by a page. We had a discussion about this. It's not ideal, but that being said, I think it's okay for us to do that if we have to, just to keep the report being fairly brief. This is such a big table. All right, so kind of moving on. All tables deserve a title. I'm going to call this Table 1, colon, space, class, coffee, cup, test, data. Right. I think that looks pretty good. We'll do that, and yeah, I think that looks great. No problems at all. Sometimes you can get rid of some of the excess spaces underneath. There we go. I made that single space just for that, and it kind of puts that table title directly above the table. Super. And remember, this is your introduction here. Okay, so moving on down to the analysis. In the analysis, you should make some kind of description or discussion, rather, of your data and what it means. So first of all, your most important information that you've developed is this heat loss rate. This heat loss rate, which is right here, really determines which cup performs the best, because something with a high number means it's losing heat quickly, and something with a low number means it's losing it slowly. Well, no surprise, the highest number, 1.45, that goes right up here with the 12-ounce paper cup with no lid, just a simple paper cup. That has nothing to help hold the heat in except a thin sheet of paper, and so it cooled off a great deal. Whereas your lowest cup right here at 0.78 appears to be the vacuum stainless steel vacuum container, which did not have a lid, but it did have the stainless steel vacuum sides, and that performed very, very well. So in analysis, you should discuss the results and identify the strengths and weaknesses of your best cup, your worst cup. And maybe, I think something that's highly important here is talk about why some cups perform better than others. Right next to that stainless steel cup at 0.79 is a standard styrofoam cup with a lid, a very inexpensive disposable solution that keeps heat in for a very low cost. So, why is it that did that? Why did the styrofoam cup without the lid perform just a little bit worse? These are questions that you can answer. In fact, the styrofoam cup without the lid performed about the same as a paper cup with a lid. Look at some of these patterns and have a bit of time to discuss why certain cups are better than others. So your analysis should be written In an objective voice, there's no need for you to go first person. If you have to, that's acceptable. But an objective voice is just simply saying what you found, what the results are, and what might be behind them without having to involve any pronouns related to people. Give it a try. It's a good voice to use in writing, academic writing, very effective. All right, finally, your discussion and conclusion. This is where you're simply going to discuss the question. Remember, you have a question right up here at the beginning of the lab. There we go. The experimental question and your hypothesis. So first start off with the experimental question. What type of coffee cup holds in the heat the best? You're going to look over these options and you're going to say, well, it's probably got something to do with cups that have lids, because both cups with lids outperformed the most similar cup to them without the lid. You'll notice these are both paper cups here, but the lid really knocked down that heat loss rate. And then you get styrofoam and styrofoam with a lid, and again, that brought it down the least. Certainly stainless steel vacuum offers an advantage, but without a lid, it's not that much better. And you can make some observations related to these. This is the ceramic mug. This is Taz, and off here to the right by itself is just another paper cup, just a larger paper cup. All right, so discussion and conclusion. You first want to talk about what makes a great cup, and then I think you should conclude based upon your hypothesis. So you're going to finish off that by going back to your hypothesis right here. Now, I wrote one that was not meant to be true, but you did your best, and you go back and answer it. So if you thought that the stainless steel cup was going to be the most effective, you can come right out and say, the data support that the hypothesis was correct. Stainless steel cup outperformed the others that showed the lowest heat loss rate. If you happen to think that a styrofoam with a lid, you can come out and say something very similar was nearly as good. If you picked a different cup, you might have to reject the hypothesis to state the hypothesis said that I thought the Taz mug would be the best. However, the results do not support this. Taz had a heat loss rate of 1.41, or excuse me, 1.17, and several cups had much lower rates than that. In fact, many of them did, with the best being either the stainless steel or the styrofoam with a lid. I'm not sure there's any meaningful difference between these two numbers. So be sure to either say the hypothesis was correct or incorrect based on the numbers, and that will finish up your lab report. One final thing. There are some instructions in writing for details. You should read them through. Make certain that things like this method gives kind of a fake method related to an unrelated lab. Don't worry about that. But when you're done, I would like you to highlight all of this material here, these instructions, and delete them out of your lab. Your lab should be a finished and final document that does not include any of this material down here. Also note down the bottom, I've included some grading, all right? And you should take a look at that. You're going to be graded on following the report instructions, using correct English with careful attention to spelling, grammar, and mechanics. Always be professional in the way that you make things look, so try to keep the format together. Your graphs and tables should certainly be proper for presentation, including capitalization, labels, headings, titles, etc. You need to have used the information correctly to identify your variables correctly and put them in the right place. And you should use data to support your answers or your discussion throughout. Use actual numbers and units to support your claims about what is best and what is not the best. Holy cow, I just realized I forgot one thing that's super important here. We never put a graph in here, and I think that you should. We've got this data table, but analysis is a great place to put that graph. And again, remember, you created this graph. You did such a nice job with it. It belongs being used. The way to get the graph in there is pretty simple. I'll remind you again, you just got to click on it to get these three dots open. Excuse me, I don't need the chart editor, and we'll close that out. Just click on it. When you see the three dots, click on those, copy the chart. Nice. And then when you want to place this into your report, it belongs in the analysis section. You can Give yourself a nice paste in. All right. It'll pop right in there. It'll look great. I think it's important to remember that it's got a nice title on its own, but the graph deserves a little bit of mention in your analysis, that you've used it to show the different cups, and maybe you can highlight the color of the cup that was the best, or whatever you're discussing at any moment. It's a great way to help identify things while you're writing your analysis. All right, I think that's about all I've got to say. Best of luck.